Hello everyone, I hope you're doing beautiful mathematics. This problem uses the idea of power of a point from geometry quite efficiently. So if you are new to the idea of power of point, this is a very good problem to put it into some practice. Remember, only if you apply theorems or ideas to problems, you learn them. Okay. This problem is from IOQM, which is the first level of Mathematical Olympiads in India. Let me quickly draw a diagram. It says that, so let me first draw a circle actually, because I have done this problem before, so I know I have to draw a circle. What you do is you use a triangle, which is an isosceles triangle like this, and it's given that this is 30, this is 20, this is 20. The picture is not very good. Of course, this is not larger than this, as I mean, in by eye estimation, but let's pretend for the moment. So BC is 30, AB is 20, AC is 20. So it's an isosceles triangle. We want to find out the perpendicular from D from A to BC. So I drop a perpendicular. Since it's an isosceles triangle, I know that it hits the midpoint. This point is D. Okay, now what we do is we mark M, which is the midpoint of this perpendicular, So let me draw a line which is parallel to BC, which is PQ, right? Which is passing through the midpoint M. Okay. Now, the goal is to find out the length of PQ. So what is PQ? What do we know about PQ? We know that it passes through the midpoint of the perpendicular, which is also the median of this isosceles triangle, and P and Q are on the circumference. So it's a chord. And we also know the dimensions, like this is 20, this is 20, this is 30. So how are we going to do it? Well, the first thing, we also know that PQ is parallel to BC. It's a very important information. PQ is parallel to BC. So how do we go about it? Okay, first thing first, we will use the midpoint theorem. Since M is the midpoint of AD, and this is parallel to BC, therefore this point T and this point R, they are also midpoints of AB and AC. It's just the midpoint theorem. So this is 10, this is 10, this is 10, this is 10. Okay. And moreover, this length TR is half of the base. So this is 30, so this is 15. This much is 15. Suppose RQ is X. This is X. And PT is also X. So here is a challenge question. This is very simple to prove, but I want you to give it a try and write a rigorous solution of this. Why is it true that RQ is equals to PT? Why is that true? You have to do some congruency argument. Okay. All right. So now that we have this, we can now use power of a point technique. It's a very beautiful theorem. I remind you what it means. If you have two chords, let's say MN and XY, and if they pass through the point, let's say R, then XR times RY is equals to MR times RN. So this times this is equal to this times this. It's a very important theorem in geometry, and we are going to directly use it here. So how do we go about it? See, AB, because if we can find out X, then we can really find out PQ. So our goal is to find out X. That's why we want to use the power of a point technique. Okay, so AB is a chord, PQ is a chord, they pass through the point T. So we can use power of point here. It is BT times TA, which is simply 10 times 10, is equals to PT, which is just x times TQ, which is 15 plus x. This is 15, this is x. So 15 plus x. TQ is 15 plus x. So 100 is equals to x times 15 plus x. So if I just multiply it out and bring everything to one side, I have x squared plus 15x minus 100 is equal to 0. So you can use middle time factorization to find the value of x. And finally, you can then add x plus 15 to get PQ. So can you give me the final answer in the comment section? Also, you can check the link in the description to go to our newly launched Panini 8 software and join the forum discussion on IOQM problems. And you can also check if your answer is correct or not. All right. Okay. Thank you for watching this video. I'll see you in the next one. Keep on doing beautiful problems. Okay. Bye.